I'm Falaah. I'm a third-year PhD student at CDS. I work with Julia Stojanovic, and I'm going to present a paper titled Towards Substantive Conceptions of Algorithmic Fairness, Normative Guidance from Equal Opportunity Doctrines. We will unpack that over the course of the talk. So here's the motivation. Algorithmic fairness and algorithmic safety have become like a talking point in the news as well, but the problem with algorithmic fairness is that fairness is a philosophical concept, not a mathematical or a formal one, and so there are multiple definitions. There's no single definition that will be applicable in all contexts. The second problem really is that we now have way too many metrics because we're a very excited community that loves defining disparity metrics, but we don't have enough guidance about which metric to use in which context and what these metrics actually say. The third problem really is that the moment we have mathematical metrics, we have trade-offs, and so what we're seeing now is that multiple metrics are not simultaneously satisfiable. And so what do you do practically when you can't have everything that you want? So here's one of the famous impossibilities. This was work done by investigative journalists, not academics, from ProPublica, that looked at this tool called Compass that was used to decide sentences for defendants who have been accused of violent crimes. And so what they saw was two concerning things. Firstly, it's the fact that the tool has a higher false positive rate for black defendants. This means that it systematically over-predicts their risk of recidivating even when they actually don't go on to do it. On top of that, it also has a higher false negative rate for white defendants, which means it systematically goes on to under-predict their risk even when they go on to recidivate. This is a double-sided problem. And so what ended up happening is this really like set into motion the community called fair machine learning, but that was pushed back by the designers of this tool. So what the designers of this tool asserted was that the tool satisfied calibration assessment, which is within groups, outcomes were calibrated. So now there really was this tension in the community about we can't simultaneously satisfy both, and so this was a couple of papers that came out, and this is very simply just from the confusion matrix of any model. You can see that you can't simultaneously satisfy false positive rates, false negative rates, and accuracy and calibration if you don't have base rates. We'll unpack this more. But the point really is that these impossibilities are fundamental. We're not going to get over them. And so maybe the point is not to debate in math, but to debate in philosophy. So the idea is instead of being metric first and trying to like sort of satisfy many, many metrics, why can't we be doctrine first? And the intuition is as follows. Mathematically incompatible measures actually encode different moral judgments. And so we don't want to, in practice, simultaneously satisfy them. We don't desire them simultaneously. And so in order to do this, we need to like move beyond just computer science. And so what we did in this work was to go read a ton of philosophy and to look at this one notion of philosophy called equal opportunity and see what those doctrines tell us and see if there's sort of a mapping between a metric and a doctrine, because the doctrines come with a mapping to a context. So for example, some doctrines only apply to certain contexts, and so then we can actually contextualize fairness. So let's jump into it. Jumping right in, what is equal opportunity? Equal opportunity is a doctrine from political philosophy that objects to any morally irrelevant factor affecting your access to desirable positions. So here we invoke Marie Kondo, sort of telling you to throw out anything that's morally irrelevant, such as gender, race, disability, and so on. What I'll tell you now was sort of missing from the computer science understanding of equal opportunity, and these are ideas from philosophy. So the first thing we do is we sort of arrange different doctrines based on different principles in order to understand which one to apply where. And so there are two principles. The first principle is the principle of fair contests or non-discrimination, which simply says if there are any barriers to access, break them. So barriers such as national origin, socioeconomic status should not affect people's opportunity to run the contest. The second principle sort of takes a broader view. So equal opportunity is not about a single contest, but about opportunities over the course of a lifetime. So not just about breaking those walls, but also look at the terrain that people have been running on. So that's really the principle of fair life chances. The second sort of structure that we'll build here in order to do this analysis is the notion of domains of EO. So the first domain, which is what fair machine learning looks at a lot, is fairness at a specific decision point. So we look at like a contest, for example, hiring or let's say college admissions as a single contest. Do you get admitted or do you not get admitted? This is usually the view. But equal opportunity asks you to look broader. It asks you to look at equality in developmental opportunities. We're all running the race, but how much access to training did each of us have? How much access to qualifications, building opportunities did we have? And are those bundles comparable? This is something that's not really looked at in the literature. The third focus is really opportunities over the course of a lifetime. And the intuition here is that when you win one contest, it sort of like fast tracks you to win later contests. And when you lose one contest, you lose access to opportunities to get better. And so it's not just enough to look at a single view, you actually have to look at opportunity sets over the course of a lifetime. Okay, so using these to sort of re-look at that impossibility result, we'll walk through two doctrines and then see what they tell us. So the prior work in this area really just had that narrow focus of like a single contest. And so what prior work did was to map different measures onto different doctrines, but only as criteria on single decision points, as if we're just running one contest all of our lives. And so we'll go into why these are wrong, and you'll have to trust me that we refuted a bunch of their claims because we have only 10 minutes. But the idea really is that we're missing something broader that philosophy is telling us here. So let's jump into it. I will cover the first two. So I gave you two principles: fair contest as single decision points, and then fair life chances over the course of a lifetime. We'll cover the first in this talk, but the other two we go into in the paper as well. So let's unpack formal and formal plus EO. So formal EO comes from this very influential doctrine from Bernard Williams that imagines a warrior society. The setup is as follows. Equal opportunity is satisfied in a society where anybody can compete to be a warrior, not just children of warrior parents. And this really goes back to like the French Revolution, where positions were distributed on the basis of like birth and basis of nobility. And so even the fact that you could say, do away with morally irrelevant factors at that time was like moral progress. Now this is clearly not enough, right? And so, the judgment really is that people should only be judged on the basis of relevant qualifications, and all outcomes should be delivered to people who have merit. So let's look at what we map this to. A common view in fair machine learning is fairness through blindness, where you just remove covariates that are irrelevant. So you just remove gender, race, disability, all of those factors, and then fit a model. But already maybe we could start thinking about how there are proxies in the data set. So even if you remove race, but you keep in something like zip code, there's a proxy that's learned through it, right? And so fairness through blindness really is a very weak, and like it's well appreciated that this is too weak for us to use. So I will omit it for now. The second mapping that we do is to map formal EO as a metric on calibration. So this is the metric of calibration, which says, for the same predicted score, S is equal to C, if people differ only on the basis of their group membership, which is now based on a morally irrelevant factor like gender, race, disability, then they should get the same outcome. This is exactly what formal EO is telling us. If the thing that's morally irrelevant is the only thing that's differing, which is A, and the thing that's morally relevant, which is the score, is the same, people should get the same outcome. So calibration across groups satisfies or encodes formal EO's moral desiderata. Okay, moving on. So let's think about why formal EO is not enough. What formal EO says is that the contest that we set up, or the test that we use to measure merit, that is what we based outcomes on. But what if the test itself is systematically skewed based on privilege? So think about the SAT. Yes, the SAT does capture some notion of like intelligence or IQ or performance, but it also captures people's preparedness, people's access to preparatory materials, the number of times they write these tests, right? And so we have another doctrine called formal plus from Fishkin, which says that if the validity of a score varies across groups, then that does not satisfy formal plus EO. And so the SAT is like a canonical example. Let's think about what this would map to. This immediately maps to error rate balance across groups. We're saying we don't want a test that systematically overpredicts or underpredicts anybody's qualifications. The first criterion is a false positive, and the second is false negative. So formal plus EO just really comes down to an error rate balance across groups. Okay, let's put this together. So I'm going to keep this statement up for a second. So this was the impossibility result. That said, absent of a perfect classifier, it's impossible to simultaneously satisfy calibration and error rate balance if base rates are different. So we'll break this down one by one. So we just saw that the calibration within groups criteria maps to formal EO. Let's see what this tells us. So S is equal to C is a predicted score based on past performance. If you think of equal opportunity as a way to sort of regulate your qualifications and the access to opportunities that build those qualifications, this is an endpoint view. We're conditioning on the predicted score. You have already built up your qualifications. Given your current qualifications, you should get a fair outcome. So this is an endpoint, backward-facing view of equal opportunity. Let's look at what Formal Plus does. Formal Plus instead conditions on the label, not on the predicted score. So let's think about what the label represents. In the context of like hiring or like admissions, the label represents your likelihood of succeeding in the position on offer, not your likelihood of succeeding in the past. So this is a forward-facing starting point view. If you think about what Fishkin was talking about, we want to accurately estimate people's future likelihood of being good warriors, or likelihood of actually doing well in the future. So this is just a starting point, forward-facing view. The third component of this framework is the base rates, or the prevalence, which was in the statement of the impossibility results. So mathematically, the prevalence is just the incidence of the label. So it's just P of y is equal to 1. So in the context of, let's say, hiring, that's just the fraction of people who get a positive outcome. So life chances is a broad philosophical concept, but you have to also remember the impossibility result applies to one single classifier, right? So if you collapse down life chances into a single metric, what you get actually is prevalence. So think about it this way. In a society where men and women had, let's say, equal opportunity to, let's say, education and CS theory, the proportion of men and the proportion of women would be the same. So like in the real world, prevalence sort of captures your life chances. Okay, putting all of this together now. I'm trying really not to go over time. Okay, putting all of this together, let's look back at the statement. The statement said we cannot simultaneously satisfy calibration across groups, which is a backward-facing view, and error rate balance, which is a forward-facing view, when people don't have comparable base rates. So what this really tells you is you can't accurately estimate past qualifications and future performance if life chances are not equal. And one thing that we have to remember is the base rates is not something we control. We can control calibration, we can control error rates, but the base rate is something the universe gives us. How many people actually get the positive outcome, right? And so so two takeaways from this really is that now we can debate in norms. Now we can start with, is our contest forward-facing, backward-facing, and what do we need? But also, we sort of need to move away from single contest views and actually do substantive EO, actually improve people's base rates. So the last idea I would sort of leave you with. So, okay, so two takeaways. One is if you come back and look at Compass and look at what Compass was saying, the thing that we're trying to predict in Compass is recidivism, which is reoffense in the future. This is a forward-looking, like the label itself is forward-looking. So it's no longer enough to look at something like calibration across groups for a context like Compass. And this is important because if we have to audit models holistically, we need to know what metric we're going to use. The second takeaway really is that let's think about why substantive EO is important. First, we said anybody who wants to be a warrior should be allowed to compete. Then we also said that what if warrior children can use their privilege to do better than non-warrior children, right? And so the problem is not solely with the test that overestimates their performance. The problem really is that warrior children will actually go on to be good warriors. So substantive EO is a lot more than sort of controlling for past outcomes, but actually improving equity in the future. And this is not something we've done at all in the landscape so far. And so the second half of the paper sort of motivates how do we do this? How do we build mechanisms that are cognizant of the future and the past, and also sort of like apply these parity constraints? I'm going to stop there. I can take questions, and I will just point you to two resources. Yeah, so we actually we were making a comic book about fairness first, and then we realized we had more work to do. So for an accessible version of everything I've said, you can read the comic. But for an updated view about the use of these in like auditing, you should read the paper. But those are my collaborators, and thank you for your attention. Any questions? Yeah? Yeah, that's a great point. Okay, so SATs is the perfect example. So I skipped the substantive conceptions. One conception is called luck egalitarian EO, which says it's not fair to compare people's effort overall. You have to compare people's effort within their distribution, because their qualifications are not a function of them, but a function of their group. And so what we're showing here is that you compare like the best within groups, the best amongst white men, black women, and so on. And so this is really what affirmative action type policies do, but then we also have a tension about whether they're effective or not, right? And there's a second line of work that talks about, like, it's called the delayed impact of fair machine learning, where you might actually see unfairness for the first 2, let's say, years, but then in the long term, you see fairness, right? And so these kind of arguments, like you mentioned, really need to be made long term, because what do you do in one cycle? Any other questions? Okay, I think we're on time anyway. Thank you.